Hello, can you hear me? Hello, can you all hear me? Okay, yep, thank you. I'll try headphones this time, see if the audio quality is a little better. Hi, can you still hear me? I put my headphones on. Okay. Is it too loud? Is it distorting? Okay, great. Okay, let's see. We have Andrew, Preeti Mishra. We have Scott, One Thing. And I guess we're waiting for the folks in Seattle. Or are any of you broadcasting this in the Seattle office yet, or no? Right, Harshad just joined. Verena Chung just joined.
Yeah.
Hi, Verena, welcome. Andrew, you have a question? Sure, go ahead, Andrew. UML drawing program. Sure. There's quite a few. One that I really like is Visual Paradigm, and it's free. You can download it here. That's one of them, Visual Paradigm. Do you see the link? Another one that's online, which is together with Google Docs. You can connect it to Google Docs. Let me just show you just a second. What's it called? If you get tools, add-ons, Lucid Charts. That's also free online. LucidChart.com. It's also a nice editor. Okay, Harshad. Harshad, are you at the Seattle office, Harshad? Yeah. Oh, sorry, that's me. Hold on. Is that Doyle? Okay. I was asking Harshad.
Yeah, sorry about that.
Yeah, Harshad, she says that she's with 7 other students. I was asking Harshad if she was at the Seattle campus with those. I wonder if she can hear me with the if she has a sound over there. Harshad, can you hear me? Okay, yeah, most everybody can hear me. I just was wondering if Harshad could hear me. Okay, Harshad can hear me. Well, let's get started. Try to get the microphone going while we continue. Okay, Doyle, Doyle is there with Harshad, but I could hear Doyle just fine. I guess with her own.
Yeah, worst comes to worst, we could use my microphone.
Okay, that's fine. And you guys are at the Seattle campus?
Yes.
Okay. All right. Great. So let's get started. Let's see. Let me bring up. Let me share my other screen. Okay. Can you all see my screen? It says diagrams done right with Lucid chart. Okay. All right. So that's one of the UML diagram tools, free diagram tools that you can use to draw your class diagrams. There's also that I in the chat, I also pointed out that you can use Visual Paradigm. That's another one that's pretty nice. It's also free with some limitation, but it's free. And that one is really nice. You can actually embed it with other IDEs such as Eclipse or Visual Studio, and you can do your class diagram, and it can generate code for you. If with the paid version, it can generate code for you, so it could do also a reverse engineering, so that if you have a set of classes, it can reverse engineering and create a class diagram for you, which is pretty cool. Anyway, so let's get going. I'm going to go to Piazza, and in Piazza, in the resources, there's a couple of slides here. I believe we covered last time all the way up to the first three set of slides. And again, if I'm going a little too fast, just let me know, and I'll pace myself. But you need to let me know. But I think the last three were pretty easy. Let's keep going, and let's keep going and see how are we converting and manipulating these class diagrams, and see if there are any limitations that things that we cannot or exactly be able to model. So let's look at relationships as constraints. Okay. Can everybody see that? Relationships as constraints. Okay. All right. So up to this point, basically, we've been looking at generating class diagrams and creating relationships with them using basically just a line between them, and perhaps adding some cardinality, saying that how many of each instance participate in the relationship. So, for instance, in this one, you have students and department, and you're saying that one department is participating in the relationship, whereas many students might be participating in this relationship. Now, by looking at this diagram, one thing that is implied from this diagram is that a student can be related at most with one department, right? So that's the relationship that we have here, and the way we implement that in a relational model is that we have a primary key on the department side, and we have a foreign key on the student side, right? That's how we implement this. And by declaring them as primary key and foreign key, we are asking the database to please enforce certain rules that we have come to call integrity constraints, right? So that for instance, it will not let us delete the department because we might have relationships with the students, right? We don't want to have the students left orphans, or we cannot, for instance, insert students and relate them to departments that don't exist, or so all these rules the integrity relational integrity are being enforced because we declare these relationships using foreign key and primary key. So referential integrity satisfies the implied constraint in this case, right? So there are some limitations of things that we cannot enforce, right? So let's look at this one, for instance. We want to see what can we enforce and what we cannot enforce. So let's look at this one. This three-way relationship where we have students, sections, and grade, right? Now in this class diagram, which is perfectly fine, there's nothing wrong with this class diagram. This says that for all combinations, notice the stars next to student and the star next to section, right? What that's saying is that we are considering many-to-many, all the possible combinations of students and sections, right? We're saying that given a particular student, that particular student can be related to many sections, or if you look at one particular section, you might be looking at, it might be related to many different students. But what's implied here is that there is a given student, even though they can be related to many sections, they're not related to, the sections cannot repeat, right, for a given student. So that's kind of implied. And the inverse is true, right? If you give one section, it is related to many students, and again, those students are not repeating, right? So the combination, what's implied here is that the combination of student and sections is unique, right? Also, what's implied here if you go to the one side of the grade, is that given any combination of student and section, there's only one grade associated in that relationship, right? So that's kind of what this diagram tells us in this three-way relationship between grade, students, and section, right? Now the problem with this class diagram is that we can't really implement this class diagram. We cannot, there's no way that we can implement this in a relational data model, right? We have to replace the receives with a more concrete, this abstract notion of this three-way relationship. The only way that we can implement this is if we replace it with something more concrete, some other class or some other table that would allow us to map the relationships between grade, section, and student. And we call this to reify, right? We reify, we make concrete that relationship receives by implementing with a physical class or physical table. And that's just fine, right? If you look at the grade assignment, you have a question?
Actually, one of my friend wants to join, but it says the Hangout is full. So
Hangout is full.
yeah.
Huh.
So I just request people who are attending from university if they can drop out.
Oh, if somebody in the university that if Doyle or Hashad is maybe Hashad or Doyle, if you're together in the same room, maybe one of you could drop out. Actually, there shouldn't be a limit though. Huh.
Not sure, but when it's trying to join, it says it's full.
Yeah, it's weird. Maybe I can send the link to her directly. Okay, we saw some people drop out, so
Okay. Yeah, I'll surely ask him to join again.
maybe is that him? How?
No, Vivek.
Vivek. Oh yeah, I saw Vivek. She sent me a Hangout request. Maybe I can send her a direct request. Let me see if I can do that. Let me see. Compose. Vivek, is that her? Vivekananda Shankar Acharya. Is that her?
Yes, that's it.
Let me send 5200. Yeah. Let's see if that works for her.
Professor, he already joined the Hangout, so
Oh, she did?
Yeah, he
Oh,
joined.
okay. Okay. Oh, he did. Sorry.
Yeah, thank you.
All right. So let me go back to where was I? I lost my train of thought. What was I talking about? This. Okay. Present. Right. Everybody can see that? Oh, I need to share. Maybe share screen. Okay. Can you all see that? Okay. I think so. All right, let me continue. So as I was saying that we replace that we replace the relationship, right? The three-way relationship with a concrete class or a concrete class table. Now, on first inspection, there's nothing wrong with this, right? We actually this is what we would need to do. But if you notice that the implied relationship that we had originally, where we said that for any combination of student section, there can only be one grade. This one, right, in this mapping table that we're using, notice that we in the mapping table we could say, well, we can basically say it's implemented how we have the grade assignment has 3 foreign keys, right? 1 foreign key to the student, 1 foreign key to the section, and 1 foreign key to the grade. And so basically we can relate of those 3 things, right? Any student with any section with any grade. And but we lose the original intent or original implied constraint, where we would say that for any given combination of student and section, we can only have 1 grade, right? There's no way that we could capture that here just with these 4 tables, right? So we lose that implied constraint that we had when we had it not reified, right? So we would like to be able to enforce that somehow. What we could do is that we could take the we could take the foreign keys. Does anybody have a question?
Yeah, oh wow, this is so hard. The slides aren't showing.
Oh, what do I do? I didn't tell it to stop sharing. Now can you see it? I see that yeah. Oh, oh, maybe if I click. Is that what's happening when I click on the slides? They go away? They shouldn't. Okay. Okay. As I was saying, there's no way that we can enforce it. One way that we could enforce it is, for instance, to take the we could take that the foreign keys of the student and section, right? We could take those foreign keys and put them together. We can combine them into a compound primary key, right? And then that compound primary key, we can say that, well, because it's a compound primary key, we would no longer allow the repetitions of those 2 foreign keys, right? If we don't if we don't add if we don't convert those foreign keys into combined primary key, we could, nothing is stopping us from repeating the same combination of student and section that was a no-no, right, in the original diagram, right? So the way we could do that is that, for instance, in the enrollment table, which is basically the grade assignment table, right, was to remove the artificial key EID, right? Take the 2 foreign keys of the student ID and section ID, combine them into a single primary key, right? And that would allow us to enforce the fact that that we wanted that uniqueness, right? So basically, we can derive a general solution to this, right? Where basically we take the foreign keys of the original. We can take the foreign keys that go off to the original weak the original weak classes, like for instance the student and the section. We take the foreign keys that go to those, and then we combine those into a compound primary key, right, to be able to recoup the original intended constraint, right? So we could fix this. That's a general principle, right? We take the student in section, we take the foreign keys, and we make a primary key out of that. But there's a limit to this principle, right?
Sorry, Professor. The
Yes?
slides went away
Oh
again.
my, why? Why is it doing that? That's annoying. Why are you doing that? Maybe because I'm making this full screen and it doesn't support full screen. Okay, I'm not going to use full screen. Maybe that's the problem. Let's see if that's let's see if that's the problem. No, again, it goes away. How about if I share the entire screen? Okay, can you see that? Ah! Can you see that, the limits of principle? All right, I'm assuming yes. All right, so the general principle assumes that the reified table has all the foreign keys. So, right, so in this case, the reified table, or the enrollment table, has all the foreign keys to the original tables. But sometimes those foreign keys are lost, right? Either because we removed them explicitly because we found a redundancy, or we saw that the relationship was not appropriate, or maybe we brought in a class into an attribute when it should have stayed as a class. So I don't know. So we made some modifications where when that reified table no longer has access to all the foreign keys. So here's an example, right, where you have perhaps student in section. Say you have student in section, and there's a many-to-many relationship, right? We have star and star on each side of the relationship, and we want to reify that, right? So we did that already, right? We reify it, and you have the two foreign keys. Well, there's no problem there. But what about over here if we add a new rule, right, that says a student can enroll in a section of a course only if the student has not taken that course before. So here's a brand new a rule that we added, right? And the many-to-many that we had originally of students in section and course is not enough to enforce this rule. We need an additional relationship that goes from this many-to-many that went between student and course to go into the section, right? Because we want to enforce the fact that there can only be one section, right? If you have not taken it before. So now, by adding this additional relationship in the class diagram, what we have done is we have introduced a cycle in the class diagram, right? Notice that we can go to course, to enrolls in, and then back to section, and then back to course. So there's a cycle there, right? Because we want to capture the fact that you've taken this course before, right? So now, this new rule forces this three-way relationship with the course. Okay. So now, obviously, we have to reify, and we follow the reification mechanism the normal way. We replace that three-way with a class. And in that class or that table, obviously, we'll have foreign keys back to the original ones. And here we have all the foreign keys, right? We have all the foreign keys, and we can certainly apply the original principle. Since we have all the foreign keys, we can create a primary keys out of those and enforce the fact that there can only be one combination between student ID and course ID. We can combine those into a single primary key and have the uniqueness there. So that it seems that we haven't lost anything here, right? Which is fine. But if we analyze this a little further, we see that this cycle over here that we've introduced has introduced some redundancy here, right? We notice that we can traverse these tables in various ways, right? We can navigate from student to enrollment to course, or we can go student enrollment section course, right? And so we could answer questions such as, what sections is the student enrolled, either going student enroll course section or student enroll section, right? And we certainly said that's a no-no, right? That we should not have more than one way to be able to answer certain queries, right? So yes, we have introduced redundancy here, and so we would certainly be in our right to remove some of these relationships, right? To remove the redundancy. But the fact is that if we do remove the redundancy, right? So this is saying that we have introduced redundancy. So we want to be able to start removing some of these redundant relationships, right? So for instance, we might want to remove enrolls and course, right? Because that's a redundant relationship, right? We could go enroll section course, right? Instead of going to the course directly. So we want to remove it. Why? Because we don't want redundancy. Because if we leave the redundancy, we have a risk of inconsistency. But if I remove that relationship, we are losing one of the foreign keys, right? If we lose that foreign key, then we can no longer enforce the constraint that was implied in the three-way relationship, right? So we're kind of left here with having to choose between two evils, right? Either we choose to leave the redundancy and enforce the constraint, or remove the redundancy and not be able to enforce the constraints, right? It's kind of a conundrum, right? Neither one of them is a good choice. Neither one is a good option. Both are equally bad, right? Both of them, if we remove one or the other, it would allow us to introduce inconsistency in the in the database, right? One thing that we could do perhaps is to leave it alone, right? Maybe choose one of the two evils that we are happier with, and perhaps solve this at the application level. So it says, I'm going to do some extra work at our desktop application level, and detect these potential redundancies, and just not allow users to do certain things, right? I'm going to enforce these business rules at the application level as opposed to enforcing them at the database level, right? And this we find ourselves doing these kinds of decisions and making these kinds of compromises all the time, right? Anyway, let's keep going here. Let's see. Any questions so far? Everybody can see the desktop. Okay, fine. Let's go on to the next set of slides. Functional dependency. So if you remember that we were going to drill for several weeks, that we would want to remove always dependencies, right?
Hey, quick question.
Yes?
So there was a part of the slides from last week we were going to cover. It was going to be aggregation and generalization, I think. Do you remember that?
Oh, yes, yes. Thank you. Thank you. I believe that was data design. You see. Last couple set of slides. Yes, let me see if it's this one. Is it? Yeah, it's this one. It's this one. Right. Yes, I believe this is where we left off, right? Composition and aggregation. Did we cover? I forget. Did we cover aggregation and composition? I can't see the chat, so I don't know if you're answering me. I'm sorry. You see? Okay. No. All right. So let's talk about that. Okay. Let's talk about that. Let's go over that. Yeah. So right. So now we did cover one-to-many relationships, right? And those are the most common ones, right? Where you have one instance associated to many other instances. And now we can further document those one-to-many by by specifying that there might be an ownership relationship, right? Not only is it one-to-many, but I can specify in addition to say that what kind of relationship are we? Am I your parent? Is there a parent-child relationship that is there a life cycle dependency, right? That says what would happen if we are in a relationship and one of us might die, right? Should if the parent dies, should the children also die, right? Is there an ownership relationship where, for instance, if I remove, say there's a purchase order, right, and those purchase order is related to many products, right? So one purchase order might be related to many products, and so what would happen if you remove the purchase order? Now, intuitively, obviously, the products would not go away, right? Even though the purchase order had a foreign key, perhaps to the product, by removing the purchase order, you don't necessarily remove the products, right? So we call that when you have an entity that has a reference to another entity, but there is no life cycle relationship, meaning that if you kill one, you not necessarily kill the other one. We say that this is an aggregation, right? That there's a part whole. One is made up of the others, but one can exist without the other, right? Whereas if you have another type of relationship, where, for instance, say I'm in Facebook and I want to remove myself from Facebook, and my expectation is that if I close my account in Facebook, all my content would go with me, right? It would also be destroyed. Obviously, this is a whimsical example. I'm sure Facebook does not remove anything, keeps everything. So from their point of view, they want aggregation. From my point of view, I would want composition, right? If I die, right? If I want to remove myself, I would want everything that is related to me, right, to also be destroyed. I want it to be as a life cycle dependency. If I die, right, if my record is removed, I would want all my posts, all my images, everything removed as well. I want a composition. I want an ownership relationship, right? I own this, right? It's mine, right? If I die, everything dies. Here's an example. If you have a person, if the person dies, the legs and hands also die. That's kind of a morbid example. But these are all of these aggregation and composition are all implied one-to-many relationships, where the one is we denote by a diamond. In a composition, we use a filled-in black diamond, whereas in an aggregation, we use an empty diamond. Okay, and we put it on the one or on the strong side of the relationship, and we put the other one on doesn't have any decorations. There are other relationships that are described in the UML diagram, which we call inheritance and generalization relationships, right? Where we might describe that we don't have an ownership relationship, but we have an inheritance or an is-a relationship. Not it has a relationship, but it is a relationship, right? And I'm sure you might be familiar with this in your when you're designing classes in any language where you can that supports object orientation, and one class extends another, or and so for instance here we have a person class capturing all the aspects that are common to several other classes, such as, for instance, the student and the professor have common attributes such as name and age. So you declare a base class person that can capture everything that is common to students and professor. Here's a how might we go about implementing this, right? How might we go about implementing this? So let's look at an example where we have a professor and student inheriting from a superclass person, right? So what we might do is declare a table person with a primary ID, primary key PID, right? That declares everything that is common, name and age, and then you declare two other tables, right? That now what we mean here is that you two tables, professor and student, that declare the fields that are specific to them, right? So the professor might have an office, and the student might have a list of grades as an array, perhaps. But notice that they have primary keys PID, right? That are both a foreign key to the primary key in person, and not only are they foreign keys, but they're also primary keys. What this says is that basically professor cannot exist without a person, right? Basically, if you're looking at from an object-oriented point of view, when you have an instance of a professor, obviously you have an instance of the office, and obviously you have an instance of name and age, right? There is no distinction, right? When you create an instance of a professor, it also has instances of name, age, and office. But in the relational model, there is no equivalence of inheritance or anything like that. So to be able to implement it, we have to say, right, that the professor is one and the same with the person by declaring its foreign key also to be its primary key. And perhaps create a cascade delete that if the professor is removed, also the person is removed, right? Or if the person is removed, it cascades to the professor, right? One cannot exist without the other. You just have, the records are, the records in the professor and the records in the person, they're just basically capturing pieces, right, of the same thing, right? Different pieces of the same idea. Does that make sense? I hope that makes sense. Student, same thing, right? The foreign key is also a primary key to the person, right? And one cannot exist without the other. If one goes, then the other should also go as well. Here's an example of a faculty that has a one-to-many with a course, right? And then notice that it has a many-to-many with a student, and then it has a many-to-many with a TA. So the course has a many-to-many with student and many-to-many with TA. And notice that TA has a generalization relationship with student, right? So student is a generalization of TA. We also say that TA is a special case or specialization of the student, right? So that means, what it means is that a student most of the time are just basically students, but sometimes students are also TAs, right? So what is a TA? Well, to be a TA, you have to be a student, right? And when you are a TA, well, not only do you have perhaps an office to enable you to do your duties as a TA, but you also have a name, obviously, that you inherit from a student. So anyway, so let's look at this little example on how you might implement this, right? So obviously, the one-to-many between faculty and course, well, that's easy, right? You have the faculty table that has a primary key, perhaps, and then the course that has foreign keys go back to the faculty. That's easy. What's challenging here is perhaps the register and the assigned, right? Those are many-to-many, so those we need to reify, perhaps by creating a registered table and an assigned table, right? That has foreign keys back to the student. And so the registered table might have foreign keys back to the student and a foreign key back to the course, whereas the assigned class might have foreign keys back to the course and back to the TA. What about the student and the TA? Well, student is just basically a student that has a name and a primary key, but the TA might have a foreign key back to the student, right? But that foreign key should also be a primary key, right, back to the student, right? So let's look at the implementation. Let's see. We have that the faculty, as we said earlier, is just a primary key in the offices, whereas the course, right, has its own fields, number, and name, but it has a foreign key that references back to the faculty. So that's easy. That's a one-to-many between faculty and course. Then here's a generalization, right? We have the student is normal, right? You have the primary key ID and the name, right? That's easy. But then the TA, right, is going to declare a primary key ID, which is also noticed not only a primary key, it's also a foreign key back to the student ID, right? and it says that, notice that there's a cascade, on delete cascade, right? That says that if the student is ever removed, then the TA also should be removed, right? It would make no sense that if you remove the TA record, that if you remove the student record, it would make no sense to keep the TA record around, right? It makes absolutely no sense, right? That if you're no longer a student, well, obviously you're no longer a TA. But not the other way around, right? We could remove the TA record, but not necessarily remove the student record, right? If you're no longer a TA, well, you might still be a student, right? But not necessarily a TA. The weak and weak relationship that we have a many-to-many, those are easy, right? We basically replace those many-to-many with reified tables. Here they are, where you have references back to the original to the other two tables, right? So the assigned has references back to the TA and references back to the course, whereas the registered, right, is also many-to-many that has references back to the student and back to the course. Okay? Anyway, so I hope that made sense. Here's another one using vehicles. Here's where you have some requirements document that explains. This is what we call prose, right? We have some English prose, just a set of paragraphs of common language explaining a problem that vehicles may be parked at a garage. Every garage has an address. Some vehicles are cars and some are boats. Every vehicle has a unique VIN and whatnot. So anyway, so notice that we can gather from the has a and from the is a, right, or can be a, right, or are. From those verbs, we can just discern certain types of relationship between these entities, right? So from here, we can discern that this is the equivalent UML diagram that captures the subclass vehicle, a sub-superclass vehicle, and then some specializations, car and boat, that inherit from vehicle, and then the one-to-many relationship between the garage and the vehicle, right? And then here's the implementation of the garage. That's easy, right? And from one-to-many relationship, you have the foreign key in the vehicle referencing back to the garage, right? So that's easy. Whereas you have the vehicle being a superclass, so that's the vehicle doesn't need to do anything. But these subclasses, car and boat, need to reference back to the vehicle, right? Notice that you have references back to the vehicle on both tables, and not only are they foreign keys, right, referencing back to the vehicle, they are also primary keys. And we are saying, if the vehicle is removed, then the car and boat need to be removed. Right? It would make absolutely no sense to remove a vehicle record but still leave the car and boat records lingering. Right? That makes no sense. Right? Association classes. So up to this point, we've been talking about mapping tables, right? Where we have a mapping table that has foreign keys back to the two other tables, right? Now, and that's fine, right? That's one particular case where we want to have a table, explaining that there's a relationship between these other two tables. But oftentimes we don't just want to say that two records are associated to one another. We might want to describe that relationship, right? We might want to describe other attributes about that relationship, right? In that case, we don't just call these mapping tables, right? And that's not the only intent, but it's that we want to maybe not just reify, right, the relationship, but we want to describe that relationship, right? In that case, we don't call them mapping tables. We might call them association classes, right? Where we're saying, and we document it this way, where we have a dash and then a class, right? That captures aspects of that relationship, right? And I mean, they're implemented exactly the same way as mapping tables, right? But not only are we capturing foreign keys, we're also capturing additional fields that capture additional attributes and describe that relationship, right? So here's an association class. where you might have flight and frequent flyer, right? Where you have, and then you have an association class that allows you to associate these two things, right? Associate flights and the frequent flyer, right? And associate bonus miles and the base miles and the flight number and so on and so forth, right? And this will allow you to have several entries that specify or decorate that the relationship between a particular flight and a particular flight frequent flyer, right? I hope that makes sense. Right. Anyway, yeah. So this is more useful. This association classes can also be used, for instance, to capture a histogram or some logging or some auditing, right? Where you want to keep track of some history on how on various relationship between two other classes, right? What has been, for instance, the history of employment on a person, right? Usually, you might have just a person and company relationship, right? The person is either there or not, right? They're either working for the company or they're not working for the company, and that might be enough to capture. But if you want to, for instance, capture the fact that this person worked from these 2 dates, they left and they came back, right? A simple primary key and foreign key won't do it, right? There's no way that you can capture that, so you want to decorate, right? Or you want to annotate and capture perhaps additional aspects of that relationship between the company and the person. So an association class is perfect, right? You say, well, I want to know your history. When has this relationship occurred, right? So an association class would allow you to capture these two things. Obviously, the way you would implement it is just like a mapping table. You would have foreign keys back to each one. But notice that in this case, there was no need to reify, right? The relationship was just fine, one to many, right? There was no need to reify this. The only reason we're introducing a mapping table is because we want to capture additional information about that relationship. Okay, so you sometimes introduce mapping tables because you're reifying. You're basically forced to be able to implement this, or because you need to capture additional information or some auditing. All right, so here's some additional information of using some employment data, and we're capturing the histogram, the history of employment of a particular employee in a particular company. Okay. All right.
Quick question.
Yes.
When would you want to promote an association class?
Oh,
as opposed to just leaving it as an association class.
Well, no, it's the same issue that we had earlier, that we had a many-to-many, and the way that you implement it is basically a mapping table, right? Is the fact that you want to reify and in that case, you're forced to implement it, right? Whereas here, you can leave it annotated this way, right? You can leave it annotated this way, but when you're actually going to implement it, right? You say, well, I'm going to just replace this, and I'm going to, replace this with its equivalent mapping class, right? For documentation purposes, you might prefer to leave it this way, annotated this way, with the understanding that the way that you're implementing it is with a mapping table in between. Okay.
Thanks.
Okay. Right. So, yeah, let's go back to functional dependencies. Excuse me. Right. So remember that we had said that we were going to that one of the main objectives when you are designing databases is that you want to avoid redundancy, right? That if you're capturing a piece of information, that ideally this would be only found in a particular place, only once, I mean, not that you cannot have repeating data. You know, if it makes logical sense that the data is repeating, that's fine. It's when logically you determine that because of the analysis of the data, this particular combination of fields should not repeat, right? It's always never by inspecting data should you you know, make a conclusion that certain things should be keys or should be non-keys or whatnot. It's always from the business analysis whether it makes sense that certain things should repeat or not, right? Or should be unique or not. So what we want to be able to do is find out, right, by looking at the fields and see how they're related to one another. If we can find any dependency between the fields, right? If the fields depend entirely on the primary key, then that's fine, right? Because the primary keys are guaranteed to be unique. Then that means that the data that we're capturing, because they depend on the primary keys, then that data would also be guaranteed to be unique, right? Regardless of whether that data perhaps is actually repeating, right? But if it's repeating because it's still the logic says that they depend on the primary key, then there's no problem, right? The problem is that if you have fields depending on each other that are not primary keys, right? If they depend on each other, then there's no way for you to enforce any uniqueness, right? Because they are not primary keys. There's no integrity constraints that would allow us to enforce any rules on those, right? So let's look at it with some examples, right? What we want to be able to do is identify dependencies between the fields, right? And we call that functional dependencies. Are there any logical relationships between the fields that, given one field, you could determine the other fields, right? For instance, if I give you a social security number, hopefully, right? If given my social security, hopefully, you could determine that that's me, right? Given perhaps my phone number, perhaps you could also determine that this is also me, right? So perhaps these could be determined to be primary keys, right? That because they're unique, right? And given one, I can definitely know the other, right? So presumably we can say that there's a functional dependency between my social security number and myself as an entity, or from my particular email and myself, hopefully, yes. So there's definitely a dependency, right? Now, if I depend on a primary key, then that's fine. There's no problem. There's a uniqueness. If I know one, it's unique. Well, the other one is also going to be unique, right? If I depend on the primary key. But if there's a dependency between fields, for instance, between my myself and my birthday, for instance, and none of those are primary keys. Say we have a primary key, which is a social security number, and then you have fields, name, and then birthday, right? Well, certainly the birthday, hopefully, if I know the person, I also know the birthday, and that should be unique, right? But if those two fields, which is birthday and the name of the person, none of them are primary keys, notice that there's no way for me to enforce the fact that one uniquely identifies the other, right? I could certainly have another record that says that here's the same name but a different birthday. There's no way for me to enforce or have the database stop me from introducing two records, the same name, right? That presumably is the same person, but two different birthdays, right? The database cannot stop me from doing that because these are not primary keys, right? There's no way for me to enforce any constraint, as opposed to if I depend on the social security number, then I can enforce the fact that if the primary key, if the social grammar is the primary key, then obviously then the other one is uniquely identified. So what we want to be able to do is identify these dependencies that, oh, well, the name depends on the primary key, so that's fine. But the birthday also depends on the name. You know, given the name of the person, then I also know the birthday. Those are non-key dependencies, right? And those might introduce redundancies, and I want to remove those. So we want to be able to identify both. Those dependencies that depend on the primary keys, and those dependencies that don't depend on primary keys. And the ones that depend on primary keys are fine, we're going to leave them alone. But the ones that depend on non-primary keys, we want to remove those, right? We want to remove. So we need to first identify all the dependencies, and then determine whether they're dependent on keys or not, right? So anyway, so let's look at a couple examples here. Here we have in this table student ID, semester, lecture, and TA. So notice in the student ID we have student ID 1201 and then the semester 4, right? And then notice that we have again 1201 and semester 4. Well, now hopefully the student ID uniquely identifies a particular student, right? And obviously, logically, right? If that uniquely identifies a person, that person can only be in a particular semester, right? So that particular person can only be in semester 4, right? So logically, if we know that person, they can only be in that semester, right? So that person can uniquely identifies the semester, right? It would be illogical, right, to have student ID 1201 for semester 4 and then in another record 1201 semester 3. That makes absolutely no sense, right? So we can logically say that there's a dependency between the student ID and the semester, right? And here we have in blue, we have student ID in red, arrow, semester in blue, right? That says that the student ID uniquely identifies the semester, or we could also write it, say that semester is a function of the student ID, right? So there's a functional dependency between the two. You're given one, I know the other, right? Given X, right? And if I churn it through a function, some logic, right? I can also determine Y, right? Obviously, we document this, or we write it formally using curly brackets, right? We use on the left-hand side, we denote the list of fields, right, that uniquely identify the other field or the other fields on the right-hand side. So, for instance, here we're saying that if you know the student ID in a particular lecture, that totally determines who the TA is for that particular semester, right? Okay. So formally, the jargon is that the left-hand side we call it the determinant set, and the right-hand side we call it the dependent set. X determines Y, or X functionally determines Y, right? If we know X, we definitely know Y, or that there's a relationship between X and Y, right? So these are all formalities for saying the same thing. Now, in our database, up to this point in the student university database that we've been looking at so far, there are no dependencies, right? Everything is beautifully designed, but somebody might come along and says, hey, here's a new requirement, right? And by adding this new requirement, right, our original design might be inadequate, right? It might be that here's a new requirement that we didn't take into account, and now our design is inadequate. This is a problem now. There might be a problem with our design. We cannot capture this new rule. So here's the rule. It says a professor can only teach one course. Okay, this is a brand new rule. It was not in the initial design, and perhaps we can enforce it by providing something like this, where we have a section that has a professor and a year offered, right? And then you have a one-to-many from the course to the section, right? And so now but notice that by introducing this rule, what we've created is a functional dependency, meaning if you know the professor, you certainly know the course, right? Because of this rule. it says, a professor can only teach one course. That means that there's a dependency between these two things, right? There's a dependency between the professor field and the CID fields, right? So there's a functional dependency. Now, whether this function dependency is good or bad, or introduces redundancy or not, or inconsistency, you have to look at it from what kinds of data would violate your new rule, right? So, for instance, when we didn't have this rule, the data at the bottom where it says Einstein teaches physics in 1950, then Einstein taught physics in 1951, and all of a sudden Einstein in 1952 was teaching dance, and then in 1953, after having realized his folly, goes back to teaching physics. Before this rule, there was no dependency between the professor and the course ID, meaning, given the professor, you really didn't know what they were going to teach that year, right? But now, because you have this rule, now there's a dependency. If you know the professor, it's definitely the course. With this new rule, for instance, now Einstein teaching dance would not be allowed anymore, right? Because given a professor, you can only teach one course, right? So now your data has inconsistency. Before it wasn't considered inconsistent, right? But now, because of the rule, now the data is inconsistent, right? If you ask the database, what does Einstein teach? You're gonna get two answers. Yeah, well, Einstein sometimes teaches physics and sometimes teaches dance, right? But because of this rule, we have now our data is redundant. Now it has inconsistencies, right? So again, data is not necessarily redundant or inconsistent until you measure it against a business rule, right? Function dependencies. Again, you have a left-hand side, right-hand side. We talked about this, right? So here's another rule. It says all sections in a year must be taught by the same professor. Meaning, the combinations of all. Well, if you say all sections, that means that it's a course, right? All the courses for a particular section. So that means that if you take all the combinations of course ID and year offer, if you know that the combination of those two things, that uniquely identifies the professor. Again, that's a functional dependency, right? Again, whether your data is now appropriate or not, and certain now, because you've introduced this new rule, all of a sudden your data has inconsistencies or has redundancy. Again, that is always measured against business rules. Before this rule, perhaps we didn't have inconsistency, but now, because of the rule, we might have certain pieces of information that now break this rule, right? So yeah, so we've basically functional dependencies as you have some set of fields on the left-hand side that uniquely identifies fields on the right-hand side. So we have these two new rules, right? We have course ID year offer uniquely identifies the section, or the professor for year offer uniquely identifies the course ID. So let's look at what would happen if we look at these two rules. If you look at one of them, notice that here we have these basic rules where we have Einstein teaching physics in 1950. That's perfectly fine, right? If you know the year 1950 and you know Einstein, well, he can only be teaching physics. And if you know that Bohr in 1951, well, that combination of Bohr in 1951, he can only be teaching physics. So all of these, they don't break any rules, right? But when you look at the other rule, right, where you have course and combination with year offer, you notice that now your data is bad, right? Against that rule, your data is inconsistent, right? It's breaking some rules. Because for a given course and a year offer, you can only have one section, not several sections, like we do here. We have several sections, right, for the same year. Einstein teaching physics in 1950 had two sections, 120 and 121, whereas Bohr in 1951 had several sections, right? So now notice that if you look at the course IDs, if you look at these functional dependencies, right? If you look at these two rules, right? Given a professor, given a year offer, right? that should uniquely identify course ID, those that professor and year offer are not primary keys, right? None of these are keys, right? But if these, so that means that there's no way for you to enforce any of this, right? This uniqueness. There's no way for you to enforce it. That's why you could have redundancy. That's why you can have inconsistency. But you could use these rules to kind of have a peek at what should be primary keys. If professor and year offer the combination of those two were keys, right, were primary keys, then this will be just fine. You can enforce this and remove the redundancy, right? You could definitely enforce the database, right, to enforce these rules, not to allow you to introduce a professor and a year offered the combination. You would force it to be unique, right? If only these were primary keys. So you could use functional dependencies as a clue of what your primary key should be, right? What are the fields that should be in your primary key, right? I mean, not that these should be primary keys. I'm saying that as a general concept, right? You could find, as you find these dependencies, these could be clues on what your primary key should be, right? So if you look at these functional dependencies and you say that you have some left-hand side K determines B, well, you could use K as a means to identify what your key should be, right? It'd be great if K were a super key, right? That some of those fields, right, would be participating in a key, right, in a primary key. If you remember, I think I don't know, I forget if it was last week, we talked about keys and super keys, right? If you remember, we said that a super key was a key, right, that might contain fields that are superfluous, right? If you remember, what that meant is that a superfluous key was a field that didn't make me any more unique, right? So, for instance, in our class, right, my last name might, last names might be enough to make us unique in our particular section. Yes. And I don't know if that's true. I haven't seen your last names. I don't know if we all have unique last names. But last names in our particular domain might be enough, right? So that might be enough to just say that's the key. Now, you might say, well, what about using last name and first name? Wouldn't that be better? Wouldn't that make us more unique? Well, yes, right? If you're considering a bigger domain, right? But in our domain, in our little class, in our particular section, perhaps, right? The combination of last name and first name, adding first name doesn't make me any more unique, right? So in our particular section, we might say that first name is just superfluous. You don't need first name to make us any more unique, right? The last name is perfectly fine as to be used as a primary key, right? So anyway, we call last name with a combination of first name, we call that a super key, meaning some a key that might contain superfluous keys, right? But on itself, all is unique, right? Last name and first name is unique. I can add my social security number. That would make it even more unique, perhaps, right? Well, actually, no. In our particular case, it would not make it any more unique, but it is unique, right? The combination of last name, first name, and social security number is unique, right? So anyway, right. So we can use these functional dependencies as clues onto what might be our choices for primary keys, right? Such as course ID and year offer. Not that that is any particular good choice of a primary key, but certainly we could use it as a clue to be able to enforce these business rules, right? So in general, we can say that if you have a left-hand side x1, x2, x3, xm that functionally determines other set of fields k1, k2, k3, all the way through kn, then we can, in general, say that x1 through xm is a super key, right? And if we start whittling down these super keys and removing any superfluous fields, we are left off with a primary key, right? Which is a super key that with no superfluous keys. We call that a full functional dependency, right? Meaning a functional dependency, which is fine because the left-hand side is made up of keys, right? It's made up of a primary key, and you can enforce this uniqueness rules between the left-hand side and the right-hand side, right? Okay, that's basically what I just said. Now, what happens when the left-hand side, you cannot guarantee that the left-hand side are keys, right? That logically it would make absolutely no sense to make the left-hand side a key. Like for instance, in our case, where you have the combination maybe of a professor and a course, right? I mean, it depends on your rules, right? On your business rules, where you have, for instance, in one field, in one record, you have the field professor and the field course, and neither one of them is a primary key, right? Meaning if you have the professor, you know the course, and you have the rule that a professor teaches the same course every year, right? If you have that rule, well, if none of these are primary keys, there's no way for you to enforce it, right? There's no way for you to enforce it because none of these are primary keys, right? And so we call this type of functional dependency, we call it a non-key based functional dependency, right? And because we cannot enforce it because none of these are foreign keys, you are almost guaranteed that you're going to have redundancies, right? That you are going to have the risk of inconsistencies where you cannot enforce it. So let's look at a couple of examples, right? Well, first of all, why do these non-key based functional dependencies even occur? I mean, why do they even appear? How do we run into this issue? How do we paint ourselves into a corner, right? Well, let's look at an example. How we might run into these functional dependencies. So let's say here's our original design back maybe last week. I don't remember where we had a student having a permit, maybe having a permit or not. It was optional, but if they had a permit, we had this nice multi-level nesting of tables relating to one another, where we were capturing the permit, the license plate. We were capturing also the car model. And the car model, we were also capturing the car maker. And this was nicely designed. And here's an example on what the data might look like. You might have many permits, and for a set of permits, you might know that those permits are all assigned to Corolla, cars that are whose model is Corolla. And maybe you have another set of permits that are assigned to Cherokees, right? Now you might have many, you might have other cars such as Corollas. You might have 4Runners and RAV4, Cherokees, Liberty, Wranglers, and all the first three, Corolla, 4Runners, and RAV4, they're all Toyotas, right? And they're nicely split off into another table, car maker, where we're capturing Toyota only once, nicely designed, right? There's no redundancy here. I mean, there's nothing wrong with this. With this design, it's perfect, right? And notice here we have Cherokee, Liberty, Wrangler. These are all Jeep, right? And this is perfect design, right? But say we made a bad design decision, and say we chose, we started saying, this is kind of dumb, we're not the registry of motor vehicles, right? We don't have the necessity to be so the need to capture the car model, the car maker. I mean, have separate tables for them. I'm gonna bring all those classes. I'm gonna bring them as attributes instead into the permit class, right? There's no real need for me to capture all those details, right? And so we might choose to have designed it this way, the permit class, right? And then brought the car model and the car maker, instead of having them as separate classes, we brought them in as attributes, car model and car maker, right? But and then after having this decision, we you know, as junior architects, we have then, you know, we run it by the senior architect, and they look at this and says, wait a minute, isn't it the case that if you have the car model, you know, if you know the car model is a Toyota, I mean, if you know the car model is a Camry, isn't that the case that the car maker has to be Toyota, right? And that if the car model is a Wrangler, that the car maker has to be Jeep? And he says, well, yeah, so, well, there's a functional dependency here, right? If you know the car model, you definitely know what the car maker is, right? So there's a functional dependency. And again, the junior architect might say, well, yeah, and what's the problem with that? Well, the problem is that you have here a non-key based functional dependency, right? Car model is not a primary key, yes? So car maker is depending on something that is not unique, right? And again, what's the problem with that? Well, let's consider what could we insert into those two fields, car model and car maker, right? For instance, you might have, for instance, several times, many times, you know, Corolla, Toyota. You know, Corolla is a very popular car, and you might have many students having the car Corolla, right? And you repeatedly have Corolla, Toyota, right? Now, this on itself is not bad, right? The problem is when you consider when somebody might inadvertently, for instance, either you know, as an error, right, introduce data such as Corolla GM, right? They introduce the car model Corolla and inadvertently choose GM as the car maker, right? And then later on, somebody might introduce Corolla and Ford, right? Now that makes absolutely no sense, right? That if you ask who the maker is of Corolla, you might get three different results, you know, Toyota, GM, or Ford. This is what we mean by inconsistency, right? We mean that you have the redundancy of Corolla and Toyota, and we have no way to enforce that one depends on the other, and that enforce them to be correct data. There's no way for us to enforce this, right? To avoid this inconsistency. There's no way for us to enforce it. And so now the junior developer, oh, I get it, okay? What we really want, right, is to be able to capture the car model once, right, as opposed to capturing, you know, so many times, right? And then what you do is in the permit, you don't capture the actual car model. Instead, what you capture is a foreign key, where this car model is declared only once, right? And in that particular case, it's captured only once, and the maker is also captured only once because it is part of the same record, which is guaranteed to be unique. You still have the dependency here, right? Notice that you still have the dependency that the maker is depending on the car model, but now the car model is not just any field, is a primary key field, right? And because it's unique, it is guaranteed to be unique. The maker is also guaranteed to be unique, right? So later on, when we visit and we talk about normalizing a database, this is exactly what we've done here, right? We have split off the fields car model and maker, right? Because we identified the functional dependency, and because we want to enforce good data, right? We split it off into a separate table, right? We call that normalizing the data, right? And one of the things that the way we realize that we need to normalize is by identifying these functional dependencies. When we find this functional dependency, it says, oh, your database is not normalized, right? You have to split it into separate tables, right? And one of the things that we're going to talk about now in normalization is that the fields like maker here, right, should only depend on the primary key, right? Actually, what we're going to say actually is that the fields, right, should depend on the key, only the key, and nothing but the key, right? Right, and those three monikers reflect different types of functional dependencies and different types of redundancies and inconsistency that we want to avoid, as we decide to split this into separate tables. I hope that makes sense. Again, please stop me if if there's any doubt. Okay, that makes sense. Here's other reasons why we might run into these redundancies, into these functional dependencies, right? For instance, we might have capture at some point, this fact that we have professors, courses, and sections, right? And we might have decided that we have a one-to-many between the one professor teaching many sections and one course having many sections, right? And this was the original class diagram that we had, right? We had the section having a primary key and having a professor, and then a course ID being a foreign key back to the course, and then the course having a primary key and a title. And we might have decided that the professor was not important enough to have them as a separate class, right? But if we introduce this new rule where the professor teaches exactly one course, how do we capture that now, right? Where the professor teaches exactly one course. Well, the original database, the original schema, had the professor and the course in the same table, right? It had them in the same table with professor and course ID. And because we introduced this new rule where the professor teaches exactly one course, it means now that we have introduced a functional dependency between the professor and the course. Notice that the functional dependency did not exist before, right? It only exists because we have introduced this function, this rule, right? Again, functional dependencies come from rules, right? So yes, we've introduced this rule, and we might have had this design at first, but we then decided that professors were not important enough to have its own class, and we brought it into the section. But because of this rule, we can no longer enforce this rule because it is not its own class, right? Wait a minute. And because it's not a key, because professor is not a key, basically we have a non-key based functional dependency, right? Means we have the risk of redundancy. We cannot enforce the fact that professor is teaching one course and then enforce the fact that the professor cannot teach another course. So the database is not going to stop us from having Professor Einstein teaching physics, but also for a separate section have Professor Einstein teaching dance or drama or something, right? The database is not going to stop us, right? Right, and the way we can enforce this is again to normalize, separate to a different into a different table, have the course ID only depend on that primary key, right? Now there's no way that we can, since Professor ID is now guaranteed to be unique, Professor ID only, course ID only depends on that Professor ID, so there's no redundancy and no risk of inconsistency. I hope that makes sense. So finally, now that we can identify a function dependency, we can formally talk about the various types of normalization. Any questions before I go on to normalization? I think this was pretty easy, right? And now that we can identify function dependency, we can talk about normal forms. Let's talk about a little bit about the various types of normal forms. Let's see. Yeah, so normalization. Let's talk about normalization in earnest. So what we want to, the whole idea of normalization again is we want to minimize or eliminate completely redundancy and avoid the risk of inconsistency. So let's look at several types of redundancy. Let's look at this one. Consider a database that where we're capturing simple things such as first name, last name, and phone number. And this was back when there were no cell phones and we only had one phone number. But today it's very easy that we have many phone numbers associated to us. We have maybe our home, our mobile, our work, so the database grew, and we have no way to capture this here, right? So the database designer might have different options. How do I do this? How do I capture the many phones for Billy Squire? One trivial way that I could do is perhaps I might decide to capture it, in a comma-separated list in the same field that I already have. I already have a field for telephones, and just if I want to capture two phones, I'll just concatenate both and just put it inside of the same field. Now, one of the bigger problems here is that now queries that used to work no longer work, right? Queries that were assuming that this was a single phone, right? That you might want to be able to reverse look up a person by phone number no longer work, right? Because now the phone numbers are not just unique phone numbers; they could be lists of phone numbers. So you can't use it as a search anymore. Also, this is, you can grow this into a list of phones, right? So you might decide to instead perhaps have it as a separate fields, right? We can have a field telephone 1, a field telephone 2, and maybe telephone 3. But then this doesn't scale very well, right? Especially not only do I need to change the schema, but it doesn't scale well. It wouldn't allow me to dynamically introduce a third or fourth or fifth telephone number easily anyway. So that doesn't scale very well either. So that's not a good option. What about this other option where you can grow vertically, right? Where you can repeatedly tell me that Billy Squire's phone number is so and so, and then in a separate record say that for the same Billy Squire, it has a different phone number, right? And that looks like it's scalable, right? We can grow vertically, adding a separate record for each time we have a brand new phone number, and that looks, harmless enough, right? Until we talk about the fact that, well, what about if I inadvertently notice that first name is not a primary key, right? And notice that first name and last name here together are not last names, are not primary keys, right? So there's no way for me to enforce uniqueness here, and so for instance, nothing would stop me from updating one of these two records that should always have the same first name and same last name. Nothing is stopping me from inadvertently, for instance, changing Billy to William, right? And now, so nothing's stopping me from doing that, and having two separate first names for the same person, Squire, last name, right? So if I want to know the first name, I would get two different answers. So again, we've introduced inconsistency into because we're being redundant. We're capturing Billy Squire, many times, right? Billy Squire, Billy Squire, Billy Squire, right? There's no way for us to say that this is the same person. So yes, we have redundancy, we have inconsistency. So what's a better solution for this, right? Well, the better solution is to split this off into a separate table. Have the telephone numbers be captured only once, and have the persons, the people here, also be captured only once. Billy Squire is only captured once. The telephone number is only captured once, right? And then you maintain some kind of relationship. We say that these are the phone numbers for record ID 456, right? And notice that this allows me first, we're not being redundant, right? Things are being captured only once, and it allows me to indefinitely grow the list of phone numbers vertically, right? I can keep adding phone numbers to Billy Squire as long as I use the foreign key 456 that matches me with Billy Squire. We call this the first normal form. Okay, if you see databases where you have this kind of layout or this kind of layout where you have comma separated values or separate fields that are capturing similar pieces of data, we say you are breaking first normal form. You have your database does not meet first normal form. Okay, and that's a bad design. Here's another one where we're not breaking first normal form. Instead, we're breaking what's called second normal form, right? Second normal form deals with the fact that our primary keys might be compound keys, where we don't have a single field in our primary key. We might have 2 or 3 fields that together uniquely identify the record. So, for instance, we have here CID is part of a key, and semester is also part of the key, but together course ID and semester are the primary key together, right? So we have a course ID and a semester. That's unique, right? The combination of the two. All right, so let's look at the other fields which are not the key, right? We have how many number of places are left in a particular course for a particular semester, and then the name of the course. Look at the name of the course. The name of the course, right? Notice that the name of the course has a logical dependency on the course ID, right? You have CS5200. Well, if you know the CS course ID, well, obviously that functionally determines, right, the name of the course, right? If you know that CS5200, then obviously that's databases. If you have CS1500, that's obviously programming. So there's a functional dependency there. Notice it's not breaking first normal form. What it is breaking is second normal form, because here we have the dependency depending on only part of the key, right? It's only depending on part of the key. It's not depending on the entire key, right? And that's a no-no, right? Okay. So we say that the fields should depend on the whole key, right? On the whole primary key, not just partial key, right? And the way we solve that is, again, we split it into 2 separate tables, where we have the course capture in a separate table, and we have the course and semester and places captured in a separate table, and we have we're using the course ID in the course table used as foreign keys back into the primary key of the CID. Okay, so that is us fixing second normal form. Here's another example where we have Alice and we have employee and skills. Those are keys, right? Together is a compound key, and so the combination is unique. So we have here Alice has 3 skills: QA, CSS, and HTML. We have Charlie has 2 skills: Java and C#. Obviously makes no sense for Alice having the same skill twice. That's why together the combination is unique, right? So that's a compound key, primary key. Notice the location on the other end, right? We have current work location. So notice that we're saying that Alice is in Cambridge, right? We're saying it 3 times. We're saying Alice is in Cambridge, right? Now notice that logically, right, Alice can't be in 2 different places at once, right? So logically, having the employee uniquely identifies, or should uniquely identify, Cambridge, right? But notice that nothing is stopping me from inadvertently changing this so that Alice, in the first record, Alice is in Cambridge, but in the second record, Alice is in Newton, or that Alice, is in Lowell, right? I mean, nothing. The database is not going to stop me from that. That's perfectly fine, right? It allows me to enter bad data, right? There's no way for me to logically force Cambridge, right? That the current location be uniquely identified by the employee, right? Because the only thing that is unique here is the combination employee skill, not employee, right? So again, the only way to fix this is to break it up into two different tables, where now Cambridge, right, the current location, work location for Alice is Cambridge. You know, for Bob is Newton, for Charlie is Newton, for Dan is Newton, right? And those are foreign keys back to the other table, employee and skill, right? Now we have the current location uniquely identified by Alice. There's no way for me to introduce, you know, bad data that Alice can be in two different places at once, right? Here's another one so for the second normal form, we say that the fields have to, you know, the non-key field have to depend on the whole key, right? Otherwise, it breaks second normal form. Okay. So here's an example that does not break second normal form, but has redundancy and has the risk of inconsistency. Let's look at this. Let's see. We have the course and year, and those two together are primary key, right? The combination. And notice that we have the course Web Dev 2012, Intro to Databases 2012, C++ 2011, and so on and so forth, right? And notice that the combination is unique, right? Notice that the professors Alice Wonderland, Bob Marley, and Charlie Garcia. And notice that they have the professor dates of birth. Alice Wonder was born in 1865. Somehow in 1865 they were teaching web development. And Bob Marley in 1945 was teaching Intro to Databases. Okay. Anyway, what we see here is that Alice Wonder, uniquely depends on the primary key web development in 2012, right? That's fine. I'm not breaking second normal form there. But notice that if I inspect here and I look at the fields one at a time, and I realize, right, that given the professor, right, there's only one possibility what the date of birth for that professor might be, right? That's a logical dependency, right? It says, wait a minute, if I know the professor, there can only be one date of birth, right? And I noticed that it is being captured several times, right? In the first Alice Wonderland is 26th November, and then Alice Wonderland again at the bottom also is 26th November. And again, there's a dependency between the fields, right? This has nothing to do with dependencies with keys or non-keys, with keys or primary keys, right? Is dependency amongst the fields, right? We find that there's a dependency that the professor date of birth depends on the professor field, right? And the professor is not a key, so we have a non-key function dependency, right? What we might want to do here, right, is to split this again, right, into two separate tables where we have the professor in the professor table, right, captured only once, right, with their particular date of birth, and that uses a foreign key back to the professor in the original table that is capturing that professor is teaching this course or the other, right? Alice can teach web development, and Alice can also teach Intro to Database. There's nothing wrong with that, right? For any particular year, right? So again, what this does is that it allows you to fix what we call the third normal form. So again, the first normal form fixes the fact that the field, the fields have to depend on the key. Have to, these numbers, these values, or Billy Squire should depend on the key. Second normal form says that it has to depend on the whole key, right? And third normal form says that it has to depend only on the key, right? That's one way to remember what each one is all about. Okay. Were there any questions? Does that make sense?
Can you repeat the first normal form, second normal form, and third normal form summary one more time?
Okay, real quick. The first one, this is kind of like a poem, I guess. The first one says, when you're normalizing, there's three things that you have to consider, right? That the non-key fields, right, should depend on the key, on the whole key, and nothing but the key, right? So it should depend on the key, right? So Billy Squire here, right? We want these three fields, right? That to be uniquely identified by the course ID, by the CID or whatever that is, right? The CD. So these, if this is unique, then these should guarantee to be unique, right? You should not find anywhere else, right, that you're going to repeat exactly the same thing over and over, right?
Sorry to interrupt. I wasn't asking for a summary of the slides. I was paying attention. You had a really quick, first normal form is this, second normal form is this, third normal form is this. That's an easy way to remember it.
Yes.
And I didn't quite pick that up.
Yeah, okay. Yeah. Yeah. As I said, the sentence to remember is there's three things here, right? There's depends on the key, on the whole key, and nothing but the key. The first one, depends on the key, refers to the first normal form. The second one, depends on the whole key, refers to the second normal form, right? That you cannot have a field that depends on partial key. It has to depend on the whole key. And the third depends on nothing but the key, right? It's a third normal form that says that you should only depend on the keys. You should not depend on other fields that are not the keys, right? Is that what you meant?
Exactly.
Okay. All right. Thank you. All right. Any other questions? All right. All right. If that's all, I think I'm gonna leave it here. I did want to point out that I did put an assignment for the. Let's see, just a second. Let me exit here. In Piazza, and the dates obviously are a little too aggressive for your section. I think we're about half a week behind. I think we're catching up to the section 2. The assignments, where is it? Where did I put it? Well, this one, UML to SQL. Let's see, what dates is that? That today is 25th. Your UML, what do we say was yours? When was that due?
The 29th.
The 29th, right? Okay, for the other section, it was due on the 23rd. Okay, yours is about a week after that. For UML to SQL, I was targeting the 5th, but that might be a little too aggressive for your section. So what I'm going to give you, I think I'm going to give you perhaps another, perhaps I'm going to make it due at the end of that week, just to give you a couple more days on that one here, okay? On UML to SQL. And also there is another assignment that's I don't remember if I made it available to you, to your section. Let me just make sure that I did. NU online courses. So here's the Boston section. Where is it? on the assignments. Here, the project topic. Okay, the project of it. I don't remember if I made it, if I put it in yours. Let me see. Just a minute. Let me make sure. Let me go into Seattle. Did I put it there? Assignments. No, I did not put it here. Okay, let me put it here. Assessment, assignment. This is the, what do I call it? What did I call it here? I called it project topic. So project topic. Okay. And basically, what I want, and you can I think you might be already ready to give me this. I made it due next week, but this should be fairly simple, and you can't go wrong in this assignment. So, oh, excuse me. You know, it should be very easy for you to get a 100 in this. What I want from you is basically a paragraph. Well, first of all, if you're forming a team, right? If you're part of a team, you know, perhaps a team of 3. I want you to list your members in your team, and have just one of your team members submit this assignment. I don't want, you know, if 3 of you in your team, don't have all 3 of you submit the same thing. We'll go and give credits to all of you in the same team. Also, what I want you to just give me, you know, just 1 or 2 paragraphs, a very short paragraph. What are you thinking on a project? Okay, you know, maybe you wanna do. A lot of you are doing e-commerce. If you could avoid e-commerce, that would be fine. I'm bored of e-commerce. The students keep doing, you know, e-commerce sites. But you know, there's a lot of things that could be done in the healthcare system. You can do things to connect to the transportation system, right? There's you can connect to all sorts of search engines, you know, mapping and geographical systems. I mean, there's a lot of cool things that could be done. Yeah. So anything that you might describe. A lot of you, many of you like sports. There's a lot of nice sports APIs out there. There's a lot of you like travel applications. A lot of you like food applications. You know, so come up with a paragraph describing, or 2 paragraphs describing your idea, and then you know, make an appointment to do a Google Hangout together, to meet during the week, within the next 2 weeks, to meet with me, to, you know, if you have questions about your topic. Also,
a quick question. I think you set the due date to the 28th, just this Sunday.
I was hoping you could come up with a short paragraph. If you think it's a little too aggressive, we could give you a couple more days. That was for the other section. When would you think would be reasonable? Perhaps an additional week? Maybe at the end of next week, perhaps?
Sure.
Maybe the end of next Friday, perhaps?
You bet. It's just nice to have a little room to work on the first homework, you know.
The project. Well, this is, you can't go wrong, right? Just come up with a project, come up with an idea, you know, of what you might want to do. What do you think you might have, how you might want to solve it? Maybe you know that Google has nice APIs to do geographical queries. Maybe you know that Yelp has a nice API to, you know, ask about restaurants. Maybe you know that Yumly has some nice APIs that to ask about recipes. and things like that. You know, you might know that the MBTA, Transportation Authority, might have information about train schedules and things like that. You know, research what's out there. A nice place that you could go for APIs is Programmable Web. Programmable Web, you know, has nice APIs that, for instance, if you want to do something about weather, if you search weather, it'll come up with various APIs that are available there, like Yahoo Weather. The Weather Channel is there. And if you go and visit them, you know, they will describe what types of queries you might think. You know, this one returns XML, right? It's a RESTful API, and it responds XML. I personally don't like XML. Yahoo Weather. Yahoo is an RSS feed and also XML. There's quite a few others. CDIN, let's see what this is. This is SOAP, right? So there's quite a few, right? So you just search around. If you find some API, you know, there's stocks, there's Yahoo stocks for financial applications. Just peruse some of these APIs that might be useful to you. And so just, you know, list any APIs that you think you might want to use. Also, you know, a rough list of pages. You know, a rough list of pages. Some of the more typical types of pages are, you know, a login page, right? Maybe a profile page that you know, when somebody logs in and displays their particular information. Maybe a search page that allows you to search for recipes, allows you to search for weather, allows you to search for, you know, airline tickets, allows you to search for restaurant reservations, allows you to search for, you know, rental or real estate information, and you know, so, you know, like a search and results page that allows you to search and show partial results, like summary of the results. Right? So that's a typical type of page. Right, and then perhaps like a details page that allows you to navigate to one of the results in the results, and then look at details. Right, so that's a very typical set of pages. Right, a login, a profile page, a search results page, and like a details page. That's a very common set of pages. Very common, but you might come up with something more clever than what I'm coming up with, right? So yeah, so think about it. There's no wrong answer to this. I think you're guaranteed to get a full credit. But I'd like to get started the discussion on what your ideas might be. And again, if you're struggling through what ideas you might have, please make an appointment with me, and we can Google Hangout together, or start a conversation. And we will, you know, we'll help you through your. Also, whatever you decide on, whatever problem you decide on, it's not set in stone. It might be that I mean, you're not familiar with those APIs yet, right? So you're not familiar with what their limitations might be. So it might be that, you know, halfway through implementing your project, you might find a very a big limitation on the API that you chose, and that's fine. You know, we might come back and revisit this project and you know, and decide what to do from there, or, you know, perhaps refocus it a little bit. Okay, but I'd like to get the discussion going. All right.
Sounds good.
All right then. I think I'm going to leave it here. If there are no more questions, everything okay? Let me go here and stop sharing. All right. Anything else?
Nothing here.
All right then. Then thank you very much. Thank you for coming. And again, make an appointment, and we can chat further about projects. All right. All right. Thank you, everyone. Good night.